Today we're looking at different types of numbers: real, rational, irrational, and a few others. The first numbers that you learned were the natural numbers. These were the counting numbers: 1, 2, 3, 4. And then notice the ... or the ellipse at the end there. That means that that list goes on forever. The whole numbers are all of the natural numbers and the number 0. So not just 1, 2, 3, 4, but also 0. The integers are all of the whole numbers and their opposites. So not just 0, 1, 2, 3, and 4, but also -1, -2, -3, -4. Notice the ... so that list continues forever in both directions. Rational numbers are numbers that can be written as the quotient of two integers. So we have several here: 0.25, which could be written as 1/4, 0.3 repeating, which could be written as 1/3, 8, which could be written as 8/1, and -4 2/3, which could be written as -14/3. These are all examples of numbers that could be written as the quotient of integers, which makes them rational. Any number where you cannot rewrite it as the quotient of integers is a number that is irrational. These numbers are things like pi, and also the square root of 3, or the square root of 2, or any square root that doesn't work out nicely. So for example, the square root of 4 is not irrational. It's actually rational, because the square root of 4 equals 2, and that could be written as 2/1, which is a quotient of integers. Real numbers are the set of all of the rationals and all of the irrationals. So any number that you can plot on a number line is an example of a real number. And that includes positive numbers and negative numbers and 0 and decimals, whether or not those decimals repeat or have patterns or not. So to summarize, we'll use a Venn diagram. You'll notice that when we were discussing these, we mentioned how the first set of numbers that you learned were the natural numbers: 1, 2, 3, ... and then they are a subset of the whole numbers, because the whole numbers have all the same numbers on them, plus they also have 0 added to it. So whole numbers are a little bit bigger than natural numbers in terms of the number of items in that set, because you have 0 in there. And then integers, that includes all of the natural numbers, it includes all of the whole numbers, but now it also adds in the negatives, or the opposites of the natural numbers. So -1, -2, -3. So that's even a larger set. Your rational starts getting the values in between these. So now we're starting to include some decimals that terminate, so they have a stopping point, decimals that have a pattern, they keep repeating, and anything that can be written as a fraction. Those are all examples of rational numbers. Remember that we said irrational numbers are numbers that are not rational, so the circle for irrational numbers does not touch or doesn't overlap with the circle for rational numbers. And also recall that we said that real numbers were all of the rationals and the irrationals together. So both of those circles are inside of the larger one for the real numbers.